June 7, 1944. Just after sunrise, high above the gray waters of the English Channel, a Luftwaffe reconnaissance pilot peered through his camera lens. Below, scattered along the Normandy coast, were unusual shadows, long and angular, hulking shapes that hadn't been there the previous day. He circled once more. The tide was low, exposing rows of massive concrete blocks, some as long as city blocks, anchored just offshore. Others floated, linked by what seemed to be floating roadways, stretching inland toward a beach that only 48 hours earlier had been soaked in American blood. He radioed headquarters. Unidentified naval structures, possibly barricades, but too large, too organized. Back in a command bunker near Kong, a German engineer named Hinrich Huber studied the grainy aerial images. He had spent most of his adult life designing coastal defenses. He knew ports. He knew bridges. But this made no sense. "These aren't barriers," he murmured. "They're constructing something. But what? How do you assemble a deep-water port without a natural harbor? How do you land 2 million soldiers, 500,000 vehicles, and 4 million tons of supplies without one? And how do you achieve it in just a few days?" The answer, as the German High Command would soon learn, was a triumph of American logistics and Allied engineering. An operation so audacious, so unprecedented, that even the most seasoned Nazi officers refused to believe it until it was too late. This is the account of how the United States and its allies built a complete port with piers, roads, breakwaters, and unloading stations. Not over months, but in mere days, right in the middle of a war zone. It was called Operation Mulberry. Yet, to the astonished eyes of the German engineers, it appeared almost magical. It looked as if America had conjured an entire city from the sea. And the truth was even more astonishing: the impossible challenge. No port, no victory. By the morning of June 7th, the beaches of Normandy were secured, at least temporarily. The cost had been immense. Over 4,000 Allied soldiers had fallen in a single day. Yet more than 150,000 had reached the shore. American, British, Canadian, and Free French forces now held a narrow, battered stretch of coastline. It was the largest amphibious assault in history, but beneath the triumph lay a problem far more terrifying than any German defenses. How do you supply an army with no harbor? How do you fuel tanks with no pipelines? How do you deliver artillery, rations, spare parts, and medical supplies for millions when there's no port? This was the real nightmare. The German command had destroyed or heavily fortified every usable harbor in northern France. Cherbourg, the nearest deep-water port, was still weeks from capture and rigged to explode. Le Havre, Calais, Boulogne, mined, bombed, and barricaded. This was no accident. It was deliberate strategy. The Germans believed that without a functioning harbor, the Allied invasion would falter, that waves of men would starve, stall, or be forced back into the sea. Hitler's Atlantic Wall had failed. But perhaps nature itself could succeed. What they didn't realize, what almost no one anticipated, was that the Allies had prepared for this very scenario. In secret, under the codename Operation Mulberry, British and American engineers had been developing, as early as 1943, a plan so daring that many commanders dismissed it as fantasy. If France had no ports, they would build one. Not in France, but in England. And not just constructed, but prefabricated piece by piece. An entire deep-water harbor. Docks, piers, breakwaters, floating roads, mooring platforms, unloading stations, everything a modern port needed to operate. Then, after D-Day, once the beaches were secured, they would tow these enormous components across the English Channel, over 70 miles of open water, through shifting tides, past floating mines and German U-boats, and reassemble them off the Normandy coast in under a week. 2 harbors were planned. One for the Americans near Omaha Beach, Mulberry A, and one for the British and Canadians near Arromanches, Mulberry B. Each harbor would surpass most industrial ports in Europe. Together, They would deliver hundreds of thousands of tons of supplies each week, sustaining the entire Allied force until permanent ports could be captured and repaired. To most observers, it seemed impossible. The scale was staggering, the logistics overwhelming, the enemy relentless, the sea unforgiving. But to American engineers and their British counterparts, impossibility was just the starting point. One senior planner, asked whether the plan could succeed, reportedly replied, "We're not asking if it's possible. We're asking how fast we can do it." And speed was essential. The Germans were already regrouping. Counterattacks formed inland. Storms brewed over the Atlantic. Every day without a port risked turning victory into disaster. The clock was ticking, and in English shipyards, under blackout curtains and the constant hum of machinery, the greatest logistical gamble of World War II was already underway. Operation Mulberry, building a port without a coast. In late 1943, while the world focused on battles in Italy and the Soviet advance in the East, another war was being fought over blueprints. Inside anonymous offices in southern England, American and British engineers gathered around drafting tables, debating the shape of floating piers, the tensile strength of steel cables, the effect of channel tides, and the load-bearing stress of hollow concrete. They weren't designing weapons. They were designing miracles. Operation Mulberry had one goal: to create two complete deep-water ports capable of sustaining an invasion without relying on a single brick from France. It began with the caissons, massive concrete blocks, each as long as a train car, towering 4 stories high, hollow inside, yet weighing over 6,000 tons. When sunk, they would form artificial breakwaters, barriers against the merciless tides of the English Channel. These were code-named Phoenix. Next came the floating piers, mile-long causeways connecting cargo ships to the beach. These weren't made of wood or stone. They were steel-reinforced pontoons, designed to rise and fall with the tide and support the weight of trucks and tanks. These floating roads were called whale bridges. Then came the mooring structures, colossal platforms nicknamed spuds, with legs driven into the seabed to maintain stability even in rough seas. These would serve as temporary docks, allowing cargo ships to unload directly onto the floating piers. To protect it all, enormous floating breakwaters called bombardons would be towed into place offshore, absorbing the worst of the waves before they hit the main harbor. Every part of the system had to be built ahead of time. There would be no time for on-site construction. After the invasion, the materials needed to be prefabricated, towed in secrecy, and assembled under fire. And so, across more than 100 sites in the British Isles, an army of engineers, dock workers, steel workers, and civilian volunteers went to work. Over 40,000 men and women labored day and night. They poured concrete into massive wooden molds. They welded steel girders in coastal shipyards. They constructed pontoons in fields miles from the ocean, then trucked them to the sea. They worked under blackout conditions in secrecy, knowing that even a single Luftwaffe raid could ruin months of progress. The numbers were staggering. Over 140 Phoenix caissons were built, each one so large it required multiple tugboats just to move. More than 10 millimeters of floating roads were constructed. Enough steel was used to build several battleships. At its peak, Operation Mulberry was consuming more raw material than the London Underground and the Hoover Dam combined. But building the parts weighs only half the challenge. The real test would be moving them, because once the beaches of Normandy were taken, assuming the landings even succeeded, there would be only a narrow window of time before the Germans regrouped. The Mulberry components would need to be towed across the English Channel, assembled with military precision, and made operational in just a matter of days. Anything less, and the entire invasion force would risk being stranded without supplies. The British took charge of Mulberry B, the Americans would handle Mulberry A, and the Navy's secret weapon, a group of unconventional builders with no military background. Naval construction battalions known as the CBS, composed of carpenters, welders, plumbers, crane operators, and machine shop workers. The CBS weren't your typical soldiers. They were middle-aged tradesmen from Iowa, Michigan, and Pennsylvania. Men who could build a barn before breakfast and fix a bulldozer in a thunderstorm. Their motto was simple: we build, we fight. And now they were preparing to Doboth on the beaches of France. In the weeks before D-Day, final rehearsals were conducted under heavy guard. Sections of the Mulberry Harbors were assembled off the coast of England, then taken apart again, towed back to staging areas, and prepared for the real crossing. Even Eisenhower was skeptical. The complexity was immense, the risks enormous. One well-placed U-boat, one rogue storm, one broken mooring line, and the whole operation could collapse. But the men working on Mulberry didn't flinch. They weren't fighting a battle of bullets. They were fighting time. And when D-Day came and the beaches were finally in Allied hands, they were ready. Ready to sail out with the harbor in pieces behind them, ready to build an entire port from scratch, right under the nose of the Reich. D-Day +1, towing a port through war. In the early hours of June 7th, while American soldiers fought to push inland from Omaha Beach, the sea behind them began to move. But it wasn't waves. It was steel. But it wasn't waves. It was steel. From dozens of English ports, Portsmouth, Southampton, Celeb, hundreds of tugboats emerged, dragging behind them the pieces of an empire. Massive phoenix caissons floating like gray tombstones bobbed in formation. Million pontoon causeways followed, coiled like mechanical snakes. The bomb burdens, floating breakwaters shaped like giant steel darts, cut through the waves silently, their purpose still a mystery to most observers. The largest pieces moved at a crawl just 3 knots per hour. It took over 24 hours to cross the channel. The sea was unpredictable. The air was full of German reconnaissance planes. And beneath the water, there was always the risk of U-boat. But the convoy pressed on. They had no choice. Every hour wasted meant more soldiers on the beach without food, without ammunition, without shelter. Every delay threatened to tip the balance of the entire invasion. When the first Phoenix caissons reached Normandy, the beaches were still raw from battle. Smoke lingered in the air. Burnt-out vehicles lined the dunes. American engineers scrambled to clear mines, mark channels, and prepare the shoreline for something no army had ever tried before. And then, quietly, deliberately, the construction began. The CBS went ashore with bulldozers, cranes, welding rigs, and blueprints soaked in salt water. Their job: assemble a floating city under fire. Working in 12-hour shifts, they sank the Phoenix caissons into position, lining them up to form a massive breakwater over 1 mile long. Each caisson was flooded in place, settling onto the seafloor with pinpoint accuracy. Behind them, the bombardons were anchored offshore, buffering the waves before they reached the main harbor. Then came the floating piers. One by one, the whale causeways were uncoiled and connected, stretching from the beach to the anchored spud pontoons offshore. Like metallic bridges rising from the surf, they flexed and swayed with the tide, but held firm. Within 72 hours of the first component arriving, trucks were rolling down those piers. Supplies, ammunition, food, fuel poured onto the beach. It was by every standard insane. Enemy artillery was still in range. Theskies weren't secure. And yet, the Americans were building an entire port in real time in the middle of a live battlefield. The Germans didn't believe the reports at first. Intercepted Allied transmissions mentioned temporary harbor activity and floating platforms. But to the German high command, it sounded like exaggeration. Maybe a few docks, perhaps pontoon bridges. But when aerial reconnaissance finally confirmed the truth, panic rippled through the Atlantic Wall. One colonel reportedly exclaimed, "This is not a supply route. This is a second invasion." German engineers were dumbfounded. The Allies had bypassed every known rule of warfare. They had ignored geography, outwitted engineering logic, and attacked not just with soldiers, but with infrastructure. This wasn't just a beachhead. It was a factory, a warehouse, a lifeline, and it was growing by the hour. In 5 days, over 10,000 tons of cargo had already passed through the Mulberry Harbors. In 10 days, that number would double. The beach, once a place of blood and chaos, was transforming into something terrifyingly efficient. And for the first time, the German commanders realized they weren't just losing ground. They were being outbuilt. The Germans react and the storm strikes. By mid-June, the reality had become impossible to ignore. From Aromanes to Omaha, the coastline of Normandy was no longer just a beachhead. It was a machine, a living, breathing port. Through the new Mulberry Harbors, over 15,000 tons of cargo were now being unloaded every single day. Jeeps rolled directly from cargo ships onto floating piers. Crates of ammunition, barrels of gasoline, and pallets of medical supplies flowed inland with mechanical precision. To the German High Command, this was not a temporary threat. It was a logistical juggernaut. In Berlin, reports from coastal observers were met with disbelief. A port built from scratch in less than a week. Some insisted it was a decoy. Others claimed the photos were doctored. But for the engineers stationed in Normandy, men like Colonel Heinrich Weber, the truth was painfully clear. They have built a harbor where there was no harbor, he wrote in a private report to Army Group B. This changes everything. Panzer divisions were mobilized to strike the beachhead. Luftwaffe commanders ordered bombing runs on the Mulberry sites, hoping to destroy the causeways and sever the Allied supply line. But the harbors had been built with sabotage in mind. Floating piers could be disconnected and repositioned. Phoenix caissons were reinforced with steel and concrete designed to absorb blasts. Bombardons shielded the structures from direct impact. Even when a section was damaged, it could be swapped out and replaced in hours. Every countermeasure the Germans attempted was too little too late. But then, nature did what the Wehrmacht could not. On June 19th, just 13 days after D-Day, a massive storm rolled in from the Atlantic. Winds surged past 60 mm waves climbed over 20 feet. It was the worst channel storm in 40 years, and hit the American Mulberry head-on. For 72 hours, wind and water battered the fragile structures. Pontoons snapped loose, causeways twisted like ribbons. Caissons were ripped from their moorings and tossed inland like driftwood. The CBS worked through the storm, tying down cables, welding ruptured joints, throwing sandbags against the wind. But it wasn't enough. When the clouds cleared, WWII was in ruins. Over 70% of the structure had been destroyed. The floating roads were mangled beyond repair. The breakwaters had been breached. Thousands of tons of cargo were lost. To the German observers, it looked like divine intervention. Radio broadcasts from Berlin declared that the American floating fantasy had collapsed under its own foolish weight. Propaganda films mocked the idea of building a port in open water, calling it Anglo-Saxon arrogance punished by the sea. But while the cameras laughed, something else was happening on the British side. Mulberry B. The second harbor had taken damage but held firm. Thanks to deeper waters, better anchoring, and slightly more protected geography near Aromanes, the British-led port remained operational. Within 48 hours, engineers had reinforced the piers, repositioned the bombard, and resumed unloading. The flow of supplies never stopped. To compensate for the loss of Mulberry, American forces adapted with staggering speed. LSTs, landing ship tanks, began offloading directly onto the beaches. Engineers reinforced causeways with steel mats and bulldozed new roads inland. The lesson was clear. You could break the harbor, but you couldn't break the will that built it. Even without Mulberry A, the Allies continued landing over 20,000 tons of supplies daily. Mulberry B operated for over 8 months, long enough to sustain the invasion, break through the German lines, and begin the liberation of Europe. In a twist no German commander could have predicted, the Americans had lost their miracle port, yet gained something even more valuable. Resilience. Because in war, brilliance matters, but adaptability wins. Broken harbor, unbroken momentum. In the days following the destruction of Mulberry, something remarkable happened. There was no panic, no retreat, no breakdown in command. Instead, the Americans pivoted. Overnight, engineers shifted strategy. Mulberry A would not be rebuilt, but the supply line would not stop. They began reinforcing the beaches themselves. Using steel matting known as Marston mats, the CBS paved temporary roadways over the sand. Bulldozers leveled dunes, LSTs. Landing ships designed for beach assaults were now used as makeshift cargo vessels, pulling up directly onto shore and offloading trucks and tanks like ferries. Amphibious vehicles called Duquebus or ducks shuttled supplies from ships anchored offshore. Pontoon causeways were extended and strengthened. Temporary piers were rebuilt using salvaged components. Each adjustment was improvisational but also strategic. The beach became a living organism, adapting, stretching, breathing. Within 72 hours of Mulberry's collapse, American forces had restored their delivery capacity to nearly pre-storm levels. By early July, they were unloading over 18,000 tons of cargo per day without a formal port. It was a stunning logistical performance. To German commanders, this defied reason. The storm had been their one shot, an unexpected ally that had done what their guns and bombs could not. And yet the Americans had absorbed the blow and kept moving. Colonel Weber, now overseeing defense coordination west of Kong, wrote bitterly in his field diary, "They have built their own system of war. It does not rely on location. It does not depend on cities or ports. It grows wherever it lands." It was more than engineering. It was mindset. The American way of war, especially in the European theater, had evolved into a doctrine of speed and flexibility. They didn't just plan for one method. They built redundancy into everything. If a harbor failed, they used the beach. If roads were mined, they laid new ones. If bridges were destroyed, pontoon replacements arrived within hours. And the numbers told the story. In the first 100 days after D-Day, over 2.5 million men, 500,000 vehicles, and more than 4 million tons of supplies were delivered across the Normandy beaches, all without a single fully functional French port. It was a scale of movement the world had never seen before and may never see again. Behind it stood the CBS, the Quartermaster Corps, the Transportation Command, and tens of thousands of civilian engineers and logisticians, most of whom would never see the front lines. They weren't in combat, but they made victory possible. General Omar Bradley later remarked, "Amateurs talk strategy, professionals talk logistics." And in Normandy, we proved that truth on every beach. Mulberry B continued to operate through the autumn, supporting British and Canadian forces as they pushed toward Belgium. But even after the capture of Cherbourg in late June and La Hara in September, many Allied commanders still preferred their improvised beach ports. Why? Because they worked. Because they had been forged under fire. Because they were American-made and battlefield-proven. By the time Paris was liberated in August, the tide of war had shifted decisively. Not just because of tanks or bombers or generals, but because of the silent miracle that began on the beaches of Normandy. A port built from scratch, a supply chain powered by grit, and a victory carried not just on the backs of soldiers, but on the shoulders of those who built the impossible and rebuilt it when it broke. The port that carried a continent, while Mulberry A had been claimed by the sea. Mulberry B, anchored off the quiet village of Aromanes, held the line. Day after day, the British-led harbor absorbed the pounding surf, the pressure of thousands of tons of cargo, and the unrelenting demands of war, and it delivered. By July, Mulberry B was handling over 7,000 tons of supplies per day. By August, that number had grown to over 10,000, and even in stormy weather, it functioned with remarkable efficiency. It was a marvel of improvisation. The British engineers reinforced the breakwaters. They doubled the anchoring cables. The floating piers were widened. The pontoon legs extended. Small naval gun crews were posted on nearby barges to provide anti-aircraft protection. What had begun as an experiment had become the backbone of Allied logistics. The village of Normandy, once a sleepy coastal town, now buzzed with life. Trucks revving, cranes swinging, forklifts unloading barrels. The beach was no longer a front. It was a factory. Through Mulberry Bass, everything from Sherman tanks to biscuits, artillery shells to bedrolls. One British sergeant joked, "You could order a cup of tea in the morning and have it shipped from England before the sun set." The port ran for 8 straight months. By the time it was decommissioned in early 1945, Mulberry B had helped deliver over 400,000 vehicles and more than 3 million tons of supplies. It had outlived its designers' expectations. It had survived storms, bombings, and the chaos of invasion. And it had shattered every preconceived notion of what was possible in wartime engineering. Meanwhile, in Germany, the mood had shifted. Reports from the Normandy front grew darker. Luftwaffe pilots returned empty-handed, unable to stop the endless stream of supplies flowing across the floating docks. German infantrymen, cut off from resupply, watched in disbelief as enemy convoys multiplied hour by hour. Inside a bunker near St-Lô, Colonel Heinrich Huber reviewed the latest reports in silence. He no longer dismissed the notion of floating harbors. He had seen the photographs, the schematics, the intercepted messages. He had heard accounts from his own officers, how trucks never stopped arriving, how Allied forces seemed to grow stronger with each passing day. He lit a cigarette with trembling fingers and muttered, "They haven't just built a harbor. They've built time, and now we are running out of it." That was the true brilliance of Mulberry. It didn't merely deliver supplies. It granted the Allies days, then weeks, then months. Every ton of cargo unloaded at Arromanches meant fewer delays, fewer shortages, fewer retreats. It meant momentum. And in war, momentum is everything. By late summer, Mulberry Harbor had enabled Allied forces to break out of Normandy, liberate Paris, and advance toward the German frontier. It had helped sustain the entire Western Front until permanent ports could be captured and restored. To the German engineers who had spent years fortifying France's natural harbors, it was a bitter irony. They had built their defenses around geography. The Americans and British had made geography irrelevant. From Normandy to the Pacific, the American art of building victory was in motion. Victory was in motion. Mulberry wasn't just a port. It was a prototype. While Allied forces pushed across Europe with floating harbors, another campaign, halfway around the world, tested the same principles under far more extreme conditions. The Pacific Theater. Here, there were no beaches like Normandy. There were jungles, coral reefs, typhoons, volcanic islands. No roads, no rails, no infrastructure, only endless ocean and hostile terrain. Yet the Americans built anyway. At places like Guadalcanal, Kwajalein, and Saipan, the Seabees returned, this time with bulldozers in landing craft and airstrips in their plans. They built floating dry docks and lagoons, constructed piers from coral rubble, and established full-service naval bases on islands barely larger than a baseball field. At Espiritu Santo in the New Hebrides, they created a forward base massive enough to house, repair, and resupply an entire fleet. In fewer than 8 weeks, they carved airfields from jungle, erected hospitals from bamboo, and transformed swamps into shipyards. The same spirit that had created Mulberry on the beaches of France now paved America's road to Tokyo, and it all boiled down to a single principle. Don't wait for the world to give you a port. Build your own. That mindset, rooted in bold engineering and logistical ingenuity, became the heartbeat of America's war effort. It wasn't just how the U.S. fought, it was how the U.S. won. While Axis powers relied on conquest to seize infrastructure, the Allies relied on invention to create it. Nothing exemplified that ethos better than Mulberry. Decades later, military historians would call the Mulberry Harbors the most audacious engineering feat of World War II. Yet, for most of the men who built it, there were no medals, no headlines. They were dock workers, farmers, engineers in borrowed uniforms. One Seabee veteran, interviewed in the 1970s, simply said, "We didn't think we were doing anything special. We just knew they needed a port, and nobody else was building one." But history remembers. Even today, remnants of Mulberry still sit off the coast of Arromanches. Some caissons remain embedded in the sand, defying tides and time, a silent monument to ingenuity under fire. Tourists walk the beaches unaware that beneath their feet lies the foundation of modern military logistics. In classrooms and war colleges worldwide, the lesson of Mulberry is still taught, not as a tale of desperation, but of design. Because what the Americans and their allies accomplished in June 1944 wasn't just an engineering marvel, it was a declaration. They would not be stopped by the absence of ports, the forces of nature, or the expectations of their enemies. While others dug in, they built out. The future of warfare, they demonstrated, would belong not to the best bunker, but to the best builder. And, perhaps most importantly, America's greatest weapon wasn't only firepower, it was imagination, to envision something that didn't yet exist, and then, brick by floating brick, make it real. The final surrender was not of armies, but of belief. Winter 1944. In a cold room outside Aachen, Colonel Heinrich Huber sat hunched over a table strewn with maps and intercepted reports. Across the Western Front, the Allied advance pressed forward like a tidal wave. Supply lines stretched but never broke. Cities fell in rapid succession: Reims, Nancy, Metz, Strasbourg. The Atlantic Wall had crumbled. France was lost. Huber, once a proud engineer of Hitler's grand coastal defenses, now stared silently at a single aerial photograph taken months earlier. The Mulberry Harbor at Arromanches. The image was grainy, but he had memorized every shadow, every line of floating road, every mooring platform. Not because he had failed to stop it, but because it had redefined everything he once believed about war. Not firepower, not manpower, not ideology, but infrastructure. "We lost," he whispered, "to something we couldn't even see coming." His words were not self-pity, but confession. For decades, the German military had worshipped efficiency, discipline, and precision, but they had not accounted for one decisive force: imagination. The Americans had not merely brought men, they had brought the future, and that future was made of concrete, steel, and vision. Mulberry was not a fluke. It was evidence of a system built to scale, adapt, and endure. Where the Nazis relied on conquest, the Americans relied on construction. While the Reich repurposed Europe's factories, the United States built its own from scratch. In just 3 years, American industry produced over 2 million trucks, nearly 300,000 aircraft, more than 80,000 tanks, and 5,000 warships. But none of those numbers mattered without the means to deliver them where needed. That was the gift of Mulberry. It wasn't the most powerful weapon of the war, it was the most crucial, because behind every soldier at the front was a road, a crate, a harbor, and behind that harbor, a worker in overalls swinging a hammer. In the decades after the war, Mulberry faded from headlines. No statues were erected, no films made, but its legacy quietly reshaped the future. Military planners reimagined doctrine around mobile infrastructure. The U.S. Army Corps of Engineers adopted new amphibious principles. NATO logistics were structured around redundancy, mobility, and rapid deployment. Lessons learned from Normandy's ghost harbor endured. Even in civilian life, the echoes of Mulberry persisted. In emergency response, offshore construction, and modular engineering, the idea that one could plan for the impossible and build for the unthinkable became more than a tactic. It became a mindset. Perhaps the greatest paradox, a structure built to be temporary, improvised, even disposable, ended up shaping something far more lasting. A way of thinking, a culture of problem-solving by making, not waiting. Today in Normandy, when the tide recedes, the broken silhouettes of phoenix caissons still stand. Children climb on them. Fishermen tie boats to them. Tourists snap selfies unaware of what lies beneath. For those who remember and study, those rusted concrete blocks are more than ruins. They are proof that when the world said, "You can't," someone said, "Watch us." When the enemy relied on nature to hold the line, the Allies built past it. When war demanded destruction, America answered with construction. So tell us, what shocks you most? That they towed a city across the ocean? That they built a functioning harbor in 72 hours? That a group of farmers and factory workers reshaped history with blueprints and blowtorches? Sometimes the greatest victories don't explode. They float. Explode. They float.